Yes. In the last video tutorial, we looked at the introduction to Matlab. We defined basic concepts like the command window, the editor, and we wrote some simple script. So we looked at the creation of Matlab files or M files. Before going any further, we should understand an important concept in computer programming, namely the use of the equal sign, which in the case of Matlab is an assignment and not an equality. Just to explain what I mean by that, in maths we are used to seeing the equal sign used to mean that two quantities are the same. So for instance, if we have two variables x and y, then the equal sign means simply that those two values are the same and x and y must also be the same type of object, right? So that's equality. However, in most computer programming languages, the equal sign is used to denote an assignment, right? In Matlab, we use equal sign as an assignment. In certain languages, they use something else for assignments, but most languages will use the equal sign as an assignment. And an assignment is not the same as equality. For instance, in an assignment, we can say x is assigned to become x plus 1. So that's how we read the equal sign in the context of computer programming, that we are now forcing the value to the left of the equal sign to become the value on the right hand side. Right? Obviously, this is not an equation. In maths, if we were to write this down and then subtract x from both sides of this, then we'd have 0 equals 1, which is obviously nonsense. So this is an assignment, and it's effectively saying force the variable on the left hand side to become the value on the right hand side. So that's what this means in the context of computer programming. And as I say in the notes down here, we can read this as saying set the value of x to become its previous value by an extra 1. So we take 1 and add it to the value of x, and that's the new value. Now that we're clear on that, we can go ahead and look at the creation of functions. So we might find as we're writing our code that we often have to perform the same sort of operation over and over again. Let's say we're working on a set of data that's provided to us in degrees Fahrenheit, and we are having to convert that to degrees Celsius. And we find that we're doing that over and over again. So instead of rewriting the same equation, instead of performing this calculation over and over again, we can create one function file which will perform this operation, and we can simply state in the code, convert this number to Fahrenheit. This concept is extremely important in computer programming. This allows us to generalize a set of commands and reuse them such that our code becomes much more elegant, much more compact, much more readable. And it also helps us start to see the equations in our code. We obtain a better connection between what we write in the computer program and what we understand as being the physical problem that we're trying to solve. So let's create a function in Matlab. Let's do it directly in the editor. So I'm creating a new file there. I just hit Control N, and the syntax for a function is as follows. So we write in function, and then the output variable for that function, let's say it's y, and then the name of the function. So let's name this function calculate y from x. Right? Of course, we have to have a single word for that. We would have difficulty processing this if there were space between any of the characters there. So let's say calculate y from x receives one argument, and let's say the operation we wanted to perform was that y was equal to x squared plus 1. So if that's the function that we often, or if that's the operation we often have to perform, then this is the function there. So there are a couple of things to notice here. First, you see that we need to use the special word function to declare to the compiler that this is going to be a function. So this is no longer a script file. Even though, as we'll see, it will save with the same .m file, this is not a script file. This is a special type. It's a function. So the variable that appears straight after the word function is understood to be the output for that, and then that's followed by the name of that function. And then here in the brackets, in the so-called argument space, are any numbers that we wish to send into that function. So we send x into this function, and that's going to return to us the value for y. So let's allow that to print its values on the screen for now, and let's just save this. Now if I hit Control S, the Matlab compiler is going to suggest that we name this function, that we give the m file for this function the same name as the function itself, and there's no reason for us to change that, so let's just accept that, calculate y from x, and let's save there. So let's look at the command window here, and of course the initializer close all, clear all, CLC. Right now you'll notice that I didn't use that in the declaration for this function, so I've cleared all the variables in the workspace, i.e. in the command window, and you'll find that I don't have such statements to clear the memory here in the function. Right? That's because we're using the function as part of some greater program. We don't want every time that we use the function in that program that it's going to clear all the variables in that workspace there. That would defeat the purpose. So this is something that we're going to use along the way in our main program, so it should not be clearing anything from the main program's memory. So now let's use this function for the value of x being 2. Right? So switching here into the command window, we say calculate y from x and let x be the value of 2 there. So this statement is going to call up this function, and where we have x, we will now substitute that for the value of 2 here. So this 2 enters into the argument space here, and then in the compiler it detects, well, I need to replace this x by the value of 2, and so we should get 2 squared plus 1, which is 5. So let's look at the result of that. So you see what comes out is y equals 5, and then it says answer equals 5. So we've got 2 lines of output here, and the reason for that is in our function we didn't suppress the output. So the right hand side ran, and then it stored that value in y, and then it would by default output that result to the screen. And that only happened because we called calculate y from x from the command window. So this is a separate operation to what's executed inside the function. So that's why we get 2 sets of outputs. On issuing the statement, it will enter the function, and then within the function y equals 5 will be returned as the screen output, and then from the statement here as well there has to be some kind of result, and that's what's shown down there. So the way to get around that, of course, would be to use the semicolon there. Let's just save it like that, and then out here we get just answer equals 5. And of course we could just suppress that output as well. We can use the semicolon there. Just remember, whenever we issue a statement in the command window, it will assign the result of that to a variable that it will create called ans, short for answer. So ans will now be the value 5. Well, it was 5 because we were using 2 before that. Let's now change this to a value of 3. So 3 squared plus 1 is 10. So we expect ans will be now 10. So let's ask for the value of ans. So here you see 10.